Hello and welcome to Unacademy, a one-stop destination for all civil service aspirants. Welcome to Science Simplified. In today's session, I will discuss India's biggest weakness, the critical minerals and rare earths. You can find the PDF of the session in my Telegram channel, the link for which is provided here. Before I start the session, a very important announcement. If you are preparing for 2027 and beyond, exclusively for you, we came up with 20% off on all UPSC subscriptions. And we recommend you to take 18 months subscription as it covers 12 months of syllabus completion courses or the comprehensive courses, and then 4 to 5 months before the prelims revision, practice and test series courses. Also with 18 month subscription, you will get a free extension for 3 months. All these are limited period offers, so do enroll before it is late. And don't forget to use the code IAS English. Let us now continue with the session. Firstly, what are the rare earth elements? They are also called as rare earth metals or simply rare earths. They are scandium, yttrium and 15 lanthanides. Scandium, yttrium and 15 lanthanides. These are called lanthanides because the series begins with the element called lanthanum. So, scandium, yttrium plus 15 lanthanides, total 17 elements in the periodic table are called as rare earths. These 17 elements are indistinguishable. It means more or less they look similar. And in the color, they are lustrous, silvery white, white in color and a little bit shiny like silver. And these 17 elements are soft, heavy metals. This is the description of rare earth elements. And now, why are they called rare earth elements? Are they really rare in the earth's crust? No, they are not truly rare in the earth's crust. But they are rarely found in high enough concentrations for commercial mining. They are rarely found in high concentrations which are enough for commercial mining purposes. Therefore, they got the name rare earth elements. Now let us see what are the critical minerals. Critical minerals are the important minerals and they are found in less quantities. And also they are not available in several countries, they are found only in few countries and we have to import them only from those countries. So they are strategically and economically very important. Such minerals are called as critical minerals. And the list of critical minerals is not the same for all the countries. It depends on the country's resource availability. Whatever elements that are present in low quantities in that particular country, they will be listed as critical minerals with respect to that particular country. Critical minerals are the materials of strategic and economic importance. And they are defined differently by different countries. The list of critical minerals is not the same in all the countries. And now we understood what are the critical minerals and what are the rare earths. Now let us see what is the relation between the two. Why are we discussing both of them together? Rare earth elements are a subset of critical minerals. It means if this circle represents critical minerals, a subgroup in that, a subset in that. These are the rare earth elements. So, rare earth elements are a subset of critical minerals. Means what? All rare earths come under critical minerals, but all critical minerals are not the rare earths. So the rare earth elements are a subset of the critical minerals. All rare earths are critical minerals, but not all critical minerals are the rare earths. These minerals are considered critical because they are crucial for wide range of applications, particularly in the energy sector, that too alternative forms of energy or the clean energy. For solar energy, wind energy, we need these critical minerals. So they are called critical because they are very crucial, very important for wide range of technologies. Also their supply chains are concentrated in a few locations. They are not found in all the countries. They are found only in few places. Only from those countries we have to import them. So frequently they are subjected to supply disruptions. For example, India imports many critical minerals from China, and depending on the geopolitical situations between the countries, when China imposes restrictions on exports, then our technologies will get affected. That is the reason why they are strategically and economically very important. Such minerals are called as critical minerals. They are important for various applications, and we have them in lesser quantities, and they are available only in few countries. So irrespective of the geopolitical situations, we have to import them only from those countries. These are the reasons why they are called critical minerals. And most importantly, the problem intensifies when the demand for the critical minerals is increasing. The demand for both means critical minerals and rare earths. I remind you once again that rare earths are a subset of the critical minerals. That is, all critical minerals are not rare earths, but all rare earths are critical minerals. So from now on, if I say critical minerals, remember that they also include rare earth elements. So both of them, their demand is expected to increase significantly with the growth in the clean energy technologies like solar panels or windmills. They all use these critical minerals. So in the near future, their demand is going to increase. Then we are considering the critical minerals and rare earths as the biggest weakness of India. So now let us see what are the important or the key weaknesses. First weakness is the import dependence. As I already told you, we have them in either less quantities or we have them in reasonable quantities, but we don't have a capacity to refine them to get the final products. On the whole, we are depending on the other countries for these minerals. So import dependence. India imports 100% of several critical minerals. Not all, 100% of a few critical minerals like lithium, cobalt, nickel. 100% lithium we are importing from the other countries. The total of the cobalt we are importing from the other countries. So 100% of several critical minerals like lithium, cobalt, nickel are being imported. And when it comes to the rare earth elements, China alone supplies 50 to 60% of India's imports. So 50 to 60% of the rare earth elements we are importing from China. So the geopolitical equations between India and China can anytime disrupt the supply from China. So this is one biggest weakness we have. The second weakness is the lack of processing or refining capacity. What is this processing and refining capacity? So here, these critical minerals are found in the form of simple minerals. and in the form of oxides. Then we have to convert them into high purity oxides. We should convert them into high purity oxides. And then from oxide form, we should convert them into metals. Means they are found in oxide forms, but we have to convert them into metallic forms. And then we should combine these metals with other elements to form alloys. As you already know, alloys are the mixtures. We should combine these metals with other elements to form alloys, metal alloys. And from the alloys, we should make the final finished products like, okay, RRPMs. RRPMs means, okay, rare earth, REPMs. Okay, REPMs means rare earth permanent magnets. Rare earth permanent magnets. We use them in the windmills, okay, for wind energy, solar panels for solar energy, and for multiple other applications. Anyway, towards the end of this session, I will also discuss the applications of the critical minerals. There we will discuss about the role of rare earth permanent magnets in detail. But these are the final product. Okay, we have mineral oxides in the earth crust. We should convert them into high purity oxides. It means we have to purify them and then convert them into metallic forms and then form alloys using these metals, and using those alloys make the final products like rare earth permanent magnets, which have various applications. So this process is called as, okay, this is called as processing or refining. Processing or refining. Okay. So the second biggest weakness that we have is the lack of processing or refining capacity. Despite possessing substantial reserves, we have substantial reserves of a few critical minerals. Still, India accounts for less than 1% of the global rare earth production. Less than 1% of the global rare earth production from India, despite having the resources in substantial quantities. Why? Due to the lack of ability to process or refine them in this procedure. Okay? Then which country is leading, okay, in this refining capacity? China currently controls approximately 85 to 90% of the global rare earth processing. Okay? Globally, the total rare earth processing or refining, if you take, 90% of this is happening in China alone. This is the reason why the critical minerals are subjected to geopolitical disturbances between the countries, because they are not available in multiple countries. They are found only in few countries, and only few countries, especially China, is having most of this refining capacity. So this is another biggest strategic weakness of India in the context of these critical minerals and rare earths. Next one, the geopolitical vulnerability. This heavy reliance on China, we are depending a lot on China. This creates major strategic vulnerability. Recent Chinese export restrictions, China imposed export restrictions on certain rare earth materials in 2025. So this exposed how fragile the Indian situation is in terms of this rare earth elements and the critical minerals. Is it clear? Okay. So heavy dependence on China in the situations like, for example, in the year 2025, China imposed export restrictions on certain rare earth elements. This exposed, it means, okay, with this we understood how fragile our situation is in the context of critical minerals. So geopolitical vulnerability is another biggest weakness. Next, limited private sector involvement and underinvestment. Government investments in this sector are less. Also, there is lesser participation of the private sector in this field. This led to lack of advanced cost-effective technologies for extraction and processing. Extraction means taking the mineral from the earth's crust, and processing means this procedure. Mineral oxides to high purity oxides to metals to alloys to the final finished products. Is it clear? Because government investment is less and private participation is also less, we could not develop advanced cost-effective technologies for both extraction of these minerals and processing them. Next one, regulatory hurdles and long gestation periods. Okay, the process of environmental approvals, because mining and extraction of the minerals and also the refining process is energy consuming, and therefore it will consume the fuels. So therefore it leads to pollution. That is the reason why this mineral exploration, extraction, refining processes needs environmental approvals and many other permits. Getting this permits is taking a long duration from 5 to 15 years sometimes. So this demotivates the private companies to involve in the exploration of these minerals and extracting them and refining them. Okay, right. So we understood what are the rare earths and what are the critical minerals and what is the relation between them and what are India's strategic weaknesses in this context. Now let us see, to overcome these weaknesses, what are the initiatives Indian government is taking? Okay, India's consumption of rare earth permanent magnets. I'll discuss what are the rare earth permanent magnets in a few minutes. Okay, in applications I'll explain what are they. Okay, but I already told you they are the rare earth permanent magnets, are the final products that we want to manufacture from this rare earths, right? Okay, so these rare earth permanent magnets, the India's consumption is expected to double by 2013. By the year 2013, the next 5 years, our consumption of these rare earth permanent magnets is going to literally double. So therefore, high strength REPMs, rare earth permanent magnets, are crucial for wide range of technologies like renewable energy, electronics, aerospace, defense and various other applications. Okay, so it means our consumption of rare earth permanent magnets is going to double in the near future, and they have enormous applications in electronics, aerospace, renewable energy sources and all, defense technology and all. But still, okay, the manufacturing is concentrated in just a few countries, with China alone controlling 90% of both manufacturing and processing capacities. This makes clear that a clear-cut strategy and a plan of action is very important in this particular field. So now let us see what are the initiatives that the Indian government is taking. In this section, I will discuss 3 important initiatives. The first one is National Critical Mineral Mission NCMM 25. Okay. The government of India launched the National Critical Mineral Mission in the year 2025. So very important. It's a part of current affairs. Under this mission, the Geological Survey of India is to conduct 1200 exploration projects. Exploration means what? Exploration is about searching. extraction is about excavation and taking the mineral out, and then refining is about making the final product. Okay, so under this particular mission, the Geological Survey of India should conduct 1200 exploration projects from 24-25 year to 2031 year. Okay, from 25 to 31, Geological Survey of India should conduct 1200 exploration projects in search of the critical minerals under the mission called National Critical Mineral Mission. Mission name is National Critical Mineral Mission in the year 2025. Under this mission, Geological Survey of India should conduct 1200 exploration projects from 24-25 to 30-31 years, and then a committee was formed by the Ministry of Mines in November 2022. This committee identified 30 critical minerals. If you remember, in the beginning of this class I told you that rare earth elements is a fixed number of 17 elements. But critical minerals list is not a fixed list. The list is different for different countries. And also the list is dynamic. I mean, a mineral which is a critical mineral today, if we find a particular mineral source, or if we develop a new exploration strategy, that particular mineral may be removed from the list because we found it. We can now explore it. It's not critical anymore. Okay. So it is country specific list, also a dynamic list. Okay. So a committee formed by the Ministry of Mines in the year November 2022 identified 30 critical minerals. Okay. In this, 24 out of this 30 critical minerals, 24 out of these 30 critical minerals are kept under Part D of Schedule 1 of Mines and Minerals Development and Regulation Act. Okay. Part D of Section 1 of Mines and Minerals Development and Regulation Act 1957. 24 out of 30 critical minerals are kept in this Part D of Schedule 1 of Mines and Minerals Development and Regulation Act 1957. What does it imply? I mean, what do you mean by keeping 24 out of 30 critical minerals in this Part D of this schedule? It means that now the central government has exclusive authority to auction mining leases. It means for these 24 minerals, now the central government can auction mining leases and composite license. What do you mean by a composite license? Composite license is a license for both exploration and mining. Okay, searching for the minerals and then extracting the mineral from the ore, mining process. Exploration, mining, license for searching, license for mining. This combined license is called as composite license. So, listing 24 out of 30 critical minerals under the Part D of the Schedule 1 of this Act means now for these 24 minerals, the central government will have exclusive authority to auction for the mining leases and also composite license for these minerals. Okay. Then what is the application of this? What is the significance of this? This encourages private participation. This encourages private participation. How does it encourage private participation? Because who will get the mining lease? A private company will get the mining lease. And who will get this composite licenses for exploration and mining? Private companies will get it. So this encourages the private participation. Okay. I repeat, National Critical Mineral Mission 2025. Okay. Under that mission, Geological Survey of India should conduct 1200 exploration projects, and okay, a committee was formed by the Ministry of Mines in the year 2022 that listed 30 critical minerals with respect to India and listed 24 out of this 30 into the part D of the Schedule 1 of this Act. It means for these 24 minerals, the central government has exclusive authority to give leases and composite licenses to private companies. Then, it also recommended, okay, I mean the mission also recommended setting up of a Center of Excellence on Critical Minerals. Okay, what is its role? Center of Excellence on Critical Minerals. What is its role? This is to regularly update the mineral list. As I told you, the list is not only country specific. Okay, critical minerals is both country specific and is also dynamic. Means, see, the Geological Survey of India is conducting the exploration projects. In this exploration, if we find a new source of a particular critical mineral, means it's not critical anymore. We can do the mining and we can get it. So therefore, the list is also not a static list. Okay. So, Center of Excellence on Critical Minerals role is to regularly update this minerals list. Next, what are the objectives of this National Critical Mineral Mission? This is to secure India's critical mineral supply chain by ensuring mineral availability either from domestic sources or foreign sources. Okay. So, what is the role of this mission? To secure the availability of the critical minerals. Let it be from domestic sources or from the foreign sources, whatever might be the source. So, to secure the availability of this critical minerals for various applications. Next, strengthening the value chains by enhancing technological, regulatory and financial ecosystems to foster innovation, skill development. It means if we give economic incentives to the private companies and loosen the regulations, it will encourage the private companies for innovation, skill development, and it will lead to global competitiveness in this particular field. So, these are the objectives of National Critical Mineral Mission. The second initiative taken by the government is a very recent development, okay, scheme to promote manufacturing of sintered rare earth permanent magnets. If you remember, I used this term rare earth permanent magnets 2 times prior in this class, but did not explain what are the rare earth permanent magnets. So let us now see what are they. Rare earth permanent magnets are high performance permanent magnets. First, they are high performance permanent magnets and they are primarily made from the rare earth elements. It means these REPMs may have other elements also, but the primary composition of them is rare earth elements. So 2 points, they are high performance permanent magnets and they are primarily formed from the rare earth elements. What are the rare earth elements commonly used in the rare earth permanent magnets? Neodymium, samarium, dysprosium. These are commonly used in the rare earth permanent magnets. I repeat, rare earth permanent magnets are strong, high performance permanent magnets, and they are primarily made up of rare earth elements. And the commonly used rare earth elements are, okay, neodymium, samarium and dysprosium. Next, what are sintered REPMs? Sintered rare earth permanent magnets means what? Okay, first of all, why this particular term? We have to make it clear. Reason is, the newly launched scheme name is Scheme to Promote the Manufacturing of Sintered Rare Earth Permanent Magnets. We already understood what are the rare earth permanent magnets. What do you mean by sintered rare earth permanent magnets? Sintered means what? These are produced by a process called as sintering. It means if rare earth permanent magnets are produced by a process called sintering, then they are called as sintered rare earth permanent magnets. Okay, so if the rare earth permanent magnets are produced by a process called sintering, then they are called sintered rare earth permanent magnets. Okay, then what do you mean by sintering? What do you mean by sintering? Sintering is, we take fine rare earth alloy powder. We first take a fine powder of rare earth alloy. We begin with that, and then okay, we compress it under high pressure. High pressure we use so that it will be okay compressed, compacted or compressed. Okay, and then they are heated to high temperature, okay, to form dense. Okay, this forms dense. Why they are dense? Because you are condensing it, pressing it, compressing it, or compacted, condensed, compressed under high pressure. So they will form dense, strong magnetic structures. Magnetic structures. They are called sintered rare earth permanent magnets. I repeat, take the fine powder of rare earth alloy, rare earth element with other elements composition combination, a fine powder of rare earth alloy, and then press this powder under high pressure so that you will compress or compact or condense it, and then heat it to very high temperature. This process is called as sintering, that is high pressure and high temperature treatment. Together is called sintering. And this sintering process will form highly dense because you are condensing it, and strong magnetic structures called sintered rare earth permanent magnets. And in general, rare earth permanent magnets are strong high performance magnets which are primarily made up of the rare earths. So, I hope with this, rare earth permanent magnets and sintered rare earth primary magnets terms are very clear for you. And I'll take you back to this point where I have written that the final products are the rare earth permanent magnets. Okay, high performance strong magnets primarily made up of rare earth elements. Okay, this is a refining process, right? Okay, then now we are discussing about this rare earth permanent magnets in the context of this scheme, recently launched scheme, the scheme to promote manufacturing of sintered rare earth permanent magnets. Okay, right. Then this particular scheme was launched on 26th November 2025, just a few days back. So this is very much into the current affairs. And government approved 7,280 crore for this particular scheme. Is it clear? This conveys how important it is to manufacture the sintered rare earth permanent magnets. The scheme will support the creation of integrated REPM manufacturing facilities. Why is the government approving this much fund for this particular scheme? What is the primary goal of this scheme? For the creation of REPM manufacturing facilities, like factories to manufacture the REPMs, okay, involving conversion of rare earth oxides to metals to alloys to finished REPMs. I hope you remember, okay. So, what this manufacturing facilities, it means what this factory will do? Will convert the oxides to metals, then metals to alloys, alloys to finished products called rare earth permanent magnets. The total duration of the scheme is 7 years, including a 2-year gestation period. Okay, and it is the first of its kind initiative and aims to establish 6,000 metric tons per annum of REPM manufacturing in India. So the target is, okay, to manufacture 6,000 metric tons of REPMs, okay, rare earth permanent magnets, 6,000 metric tons of REPMs per year. That is the target. For that, this scheme is launched, okay, with the approved funding of 7,280 crore rupees, okay. Then this is to enhance the country's self-reliance and positioning it as a key player in the global REPM market. What is the final goal of this mission? To keep India as one of the global players in the like rare earth permanent magnets market, okay. So, 2 initiatives we completed. The first initiative is National Critical Mineral Mission 2025, okay. The second initiative is the scheme to promote manufacturing of sintered rare earth permanent magnets, launched few days back, 26 November 2025. The third initiative is, okay, to set up a national critical mineral stockpile to keep a reserve of this critical minerals. In the case of any supply chain disturbances due to geopolitical relations between the countries, we should keep a stockpile, okay, of critical minerals for at least 2 months in reserve to mitigate the supply disruptions. These are the 3 primary initiatives that the Indian government is taking, okay, to overcome its biggest weakness, that is critical minerals and rare earths. Now, we entered into the final segment, that is applications of the critical minerals. Why are we discussing so much about them? What are the uses of these critical minerals? And I remind you, critical minerals include rare earth elements, right? Then first application is solar energy. Critical minerals such as silicon, tellurium, indium, gallium are vital for the production of photovoltaic cells. So, let us understand what are the photovoltaic cells. These are the electronic devices that convert light energy directly into electrical energy. Light energy directly into electrical energy. Directly into electrical energy means what? In between there is no conversion into heat energy. It is not like light energy to heat energy and then heat energy to electrical energy, not like that. Light energy is directly converted into electrical energy by certain electronic devices. Those devices are called photovoltaic cells, and this effect is called photovoltaic effect. Okay, their capacity to convert like this. Okay, the devices are called as photovoltaic cells, and that capacity to convert, light energy directly into electrical energy, that capacity is called as photovoltaic effect. Okay, then the critical minerals like silicon, tellurium, indium, gallium are very important in the manufacture of photovoltaic cells. In simple layman language, the solar panels that we keep in the farms, terraces, those are the photovoltaic cells. Okay. India's current solar capacity of 64 gigawatts is heavily dependent on these minerals. Okay, we are generating 64 gigawatts of electricity from the solar energy. For this purpose, critical minerals are very important. Second applications, wind energy. Rare earth elements like dysprosium, okay, samarium and neodymium are used in permanent magnets for wind turbines. Windmills, a fan-like thing will keep rotating, that will convert the kinetic energy, mechanical energy, kinetic energy into electrical energy. So those windmills also use critical minerals. India aims to increase its wind energy capacity from 42 gigawatts to 140 gigawatts by 2030. This necessitates the critical minerals. Third one, we use critical minerals in the electrical vehicles also. You know, EVs use lithium ion batteries. So lithium, nickel and cobalt are the key material used in the lithium ion batteries, and also rare earth permanent magnets. I already explained what are they. These are the strong high performance permanent magnets made primarily using the rare earth elements. These rare earth permanent magnets are also used in the electrical vehicles motors. Lithium ion batteries require lithium, nickel, cobalt are used in the batteries, and also we use rare earth permanent magnets in the motors of the electrical vehicles. Next one, we also use them in the energy storage, like lithium ion batteries use lithium, cobalt, nickel. Then we use in the electronic devices, like our mobile phones, laptops use lithium ion batteries. So lithium, nickel, cobalt are the critical minerals. So we need critical minerals for the mobile phones, laptops and semiconductors, fiber optic cables, data centers, all of them also use these critical minerals. We also use them in the defense technology. Critical minerals are, they enable advanced radar, you know radar, radio detection and ranging. We use radars in space technology, defense technology, okay, and also in the electronics. And sonar, sound navigation and ranging, that is sound waves are sent and then the echoed back sound waves will be studied to identify which surface it is, okay. Also in the laser guidance systems and precision guided munition, weapons, missiles, okay, for them we use critical minerals. We use critical minerals in radars, sonars, laser guidance systems, precision guided munitions, explosives, like munitions, etc. Next, we also use them in phosphors. So what are the phosphors? Not phosphorus, phosphors. What are they? These are the luminescent material that emit light when exposed to UV light. If this mineral is kept under the UV light or subjected to the flow of the electrons through that, then it will emit the light. Okay? Certain minerals, certain material that emit light in response to exposure to the UV or electrons. They are called phosphors. These phosphors are used in the screens and LEDs. These are all the applications of critical minerals including the rare earths. So therefore, overcoming this biggest weakness in the critical minerals and rare earth elements is very crucial for India. That's all for this session. Thank you so much.